Welcome to Lakeside Physics. This video will give you an introduction to vector addition. Let's begin with a conversation with a couple of our physicists.
Hey guys, I've got a question for you. Let's say I walk 4 meters and then I walk 3 meters. What's my displacement?
It's Friday. That's easy. 7 meters, right? 7. Yeah, you sure? Yeah. Walk. Yeah, 7. Are we talking displacement? All right. Why not negative 7? I can walk backwards. Okay. Granted. Okay, it's negative 7. 7 or negative 7 seems pretty good to me. Why not 1? How do you get 1 out of the... You're going to walk again. Okay, 4 forward, 3 backwards, 1, or negative 1. Oh, there we go. Nice. I wasn't thinking about negative 1. Yeah. What about 5? 5, let's see. How can you do that? It's either 1 or 7, isn't it? 1, 2, 3, 4. 1, 2. Clever man. Okay, you're right. Well, if it's, in that case, if you can change the angle, then it's anywhere between 1 and 7 in magnitude. So I can't go 10. No, because there's no way you get 10 from a 3 and a 4. Sure about that? I'm fairly confident. Yeah, you're right. So our answer, between 1 and 7, magnitude.
All right, so there you have it. I could go anything from 7 meters to 1 meter to anywhere between 1 and 7 meters. We are going to consider a vector to be a mathematical quantity. Just as we've talked about before, it can have magnitude, that's the how much, and the direction where. Vectors are visually represented by arrows. The length of the arrow tells you the magnitude. The direction of the arrow tells you the direction. Vectors are mathematically represented by letters, either bolded letters or letters with an arrow over the top of them. Examples of vectors. Player advanced 10 yards down the field. Wind was blowing out of the north at 15 miles per hour. A rocket exerted 15 pounds of thrust upwards. In all of these cases, we have the magnitude and the direction. So now we're going to consider how to add vectors. Vectors cannot be added normally. I can't take 3 plus 5 and get 7 every single time. I've got to consider what direction those vectors are going. There's 2 methods to add vectors, adding graphically and adding by components. Subtracting is just adding the negative of the vector. So the negative of the vector has the same magnitude, but just the opposite direction. So let's start by looking at adding graphically. What you want to do is basically create a visual representation of the summation by drawing the vectors. It provides a quick estimate of the direction and magnitude of the resulting vector. It tends to be inaccurate because any attempted accuracy requires careful measurement using protractors and rulers, which people don't always tend to do. Pause the video right now and go ahead and write down these 5 steps to adding graphically, and then I will talk you through them with vectors. Okay, so let's begin. Imagine we've got 2 vectors, A and B. Vector A is pointed at 36.87 degrees south of west is one way that you could say it, or south, in the negative 36.87 degrees down from the negative x-axis. 5.0 newtons, this is a force, we'll be talking about forces later, and vector B is pointing up and has a magnitude of 4.0 newtons. So first thing you're going to do is designate the origin, pick a place for the origin, draw the first vector to scale with the tail starting at the origin. You will then draw the next vector at the tip of the last vector. So the tail is at the tip of the last vector. And you need to make sure that the vectors are the correct magnitude and are pointing in the correct direction. You then, if you had any more vectors, you continue to place them tip to tail until all the vectors were drawn. And your resultant vector will extend from the origin or the tail of the first vector to the tip of the last vector. Now you take this new vector that you just found, you measure the magnitude to scale and the direction, and then that is your vector. So when I added A plus B and I measured this with a ruler and a protractor, I got 2.1 newtons at 14 degrees above the negative x-axis. You can also take a b plus a is still the same thing. So just a note that b plus a is equal to the same thing as a plus b. All right, let's now consider our second method of adding vectors, adding by components. This is the one you will be using most frequently. So the idea is that all vectors can be broken down into two components, vectors that lie along the x-axis and that lie along the y-axis. So we can take our a vector and break it up into an x component and a y component. While you cannot simply add vectors because they tend to point in different directions, you can add vector components that lie along the same axis. So if we break up each of our vectors into an x component and a y component, we'll be able to add those parts of the vectors. Now take a moment and pause the video, write down these steps, and then I will work you through them step by step, using our A and B vectors as an example.
Hey Tom, still thinking about vectors? Nope. Get with it, we have more to go.
All right, so let's go ahead and talk through an example. We're going to begin by breaking up the components using sine and cosine into pieces that lie along the x-axis and the y-axis. A table is often useful to use, and you want to be careful to keep track of your signs. So let's begin by breaking up A into its x component and its y component. Its x component is going to be 5 times the cosine of 36.87 degrees. Remember your SOHCAHTOA. The cosine is adjacent over hypotenuse. So cosine of the angle is equal to a sub x over the hypotenuse 5, or a sub x is 5 cosine of the angle. And then y will be our opposite. So sine is opposite over hypotenuse. It is your, the a sub y component is 5 times the sine of 36.87 degrees. Notice the negative signs. For both a sub x and a sub y, they are pointed in the negative direction. Notice that I chose this special angle of 36.87 degrees because it is part of a 3, 4, 5 triangle. Our B is a little bit easier because it's only pointed in one direction. Our B sub x component is 0, and our B sub y component is just positive 4 newtons. So then we just sum the vector components that lie along the same axis. So I sum up all of the x components, I get negative 4 newtons. I sum up all the y components, I get positive 1 newton. Now I basically reassemble this resulting vector by using tangent in the Pythagorean theorem. So go ahead and draw your vector, negative 4 newtons in the x direction, and then positive 1 newton in the y direction. Our summation of these two is the a plus b, and I can use the magnitude I can find by using Pythagorean's theorem, taking the square root of x squared plus y squared gives us 4.1231 newtons. And then I can use tangent to find the angle. So I'm going to take the inverse tangent of y over x, or 1 over 4, and this gives me 14 degrees. Now, rounding to the correct sig figs, I get 4.1 newtons at an angle of 14 degrees above the negative x-axis, as I found before. That finishes our video on vector addition. Remember, there are two ways to add vectors, adding vectors graphically and adding vectors by components.
So I hope that video pointed you in the right direction. Really? You had to do that?